Welcome to Delegated Design of Metal Stair Systems. Webinar is sponsored by Lapeyre Stair. Today's webinar is hosted by Ron Plank and Associates, and I'm Andrea Lingwell, your moderator. Participants will be receiving one AIA LU CE hour for completing today's course. All registered attendees who meet the time requirement will receive a thank you for attending email from webinars@ronblank.com. Handouts, documents, and the recording for today's webinar will all be included within that email. But also, if you look on your dash in the handout section, you will see that I've uploaded this handout for today's presentation. If you are attending and have a group participation under your login, you are considered to be a group manager. Now, as that manager, I need you to report your attendance within 24 hours of receiving the thank you for attending email. Once you open up that email, you're going to look for the Submit Attendance Using Group Submission Form link. You'll then click on that and enter in your group's information. Then that way I can get their certificates and their credits for being with us today. All certificates will be emailed from webinars@ronblank.com. So if this is not already added to your Safe Senders list, I suggest you do that as soon as possible. This will help prevent your certificate from going into your junk or your spam folder. Once you've received that thank you for attending email, you will then have access to your certificate on your Ron Blank account. All you need to do is log into your account. You're going to hover over the orange welcome back and then click on My Transcripts. From there, you will then click on Webinar Courses. You will then see all the webinars that you have participated and be able to view or email your certificate from within there. Participants are in a listen-only mode during the webinar presentation. However, if you have questions at any time throughout the duration of today's webinar presentation, you can enter them in at any time. All you need to do is click that plus button or the little arrow button to expand the question panel. And then from there, you can enter in your questions. Now, once we get to the Q&A portion of the webinar, I will pull questions from there to get you guys answers. If we do run out of time, no problem. I will have the presenter email you in regards to getting you answers to your questions that we weren't able to. Also, just if you experience any technical difficulties, whether audio or visual drops out at any time throughout the presentation, what I want you to do is completely log out of the webinar and then log back into it. That typically fixes it about 99% of the time. However, technology has a mind of its own from time to time. And if you're still experiencing any technical difficulties, send me an email at webinars@ronblank.com and I will assist you from there. So without further ado, our presenter for today is Ashton Pratt. Ashton is the commercial manager for Lapeyre Stair, Inc. In his 10+ years experience in the metal stair industry, Ashton has managed commercial and industrial projects ranging from 2-story low-rise to 70-story low-rise. He has provided technical consulting to design professionals, contractors, and engineers on best practices to specify, design, and coordinate the material stair delegated design process. Ashton's practical experience and commitment to continuing learning helps provide a unique training experience for design professionals wanting to improve coordination of the manufacturer's metal stair within their overall project. Thank you so much, Ashton, for being with us today, and I am turning it over to you, sir.
Okay. Thank you, Andrea. And hello, everyone. Welcome to our course, Delegated Design of Metal Stair Systems. My name is Ashton Pratt, and as Andrea mentioned, I'm the Commercial Operations Manager at Lapeyre Stair, and I've been working in the metal stair industry for about 10 years and have worked with architects and engineers all across the country to help improve metal stair design for better efficiency, functionality, and safety. And I am excited to be here today and would like to thank everyone for joining us. As Andrea mentioned, this course is registered by Ron Blank and Associates, and if you have any questions in regard to the credits you will be receiving, please contact Andrea at the email address she has provided. In this session, I will walk through the overall process for the delegated design of metal stair systems, focusing on the coordination and flow of communication between the different design parties. That includes the architect, engineers, contractors, and metal stair manufacturers. Over the last several years, new technologies and more stringent criteria for metal stair design have emerged. So understanding the roles of each party is important to achieve the maximum benefit of the process and eliminate issues and bottlenecks. This course will help architects, one, describe the delegated metal stair design process and how the roles of each party can increase the safety and efficiency of a project. Explain the benefits of a delegated metal stair design process and how it ensures a safe and durable installation. Discuss the best practices of documentation, BIM coordination, and information flow required throughout the process. And then identify key issues, bottlenecks, and sources of error within a delegated metal stair design process and understand how to eliminate them. So I'll start with just a brief overview of the delegated design process in general and how it relates to metal stair systems. The delegated design process, it's been practiced for many decades. Not until 1997 was it officially adopted under the AIA document A201, General Conditions of the Contract for Construction. And in this document, the AIA inserted the language that must be included for the scope of work to be considered design delegation. And the general definition is that design delegation is design of building components or equipment by someone other than the building designer. It can be performed by the contractor, subcontractor, or equipment manufacturers or fabricators. And it's typically used when components or specialty equipment require specialized engineering skill and know-how, and when the components may differ depending on the chosen solutions. So for instance, with metal stairs, they require design of many different connection details and components, and each manufacturer will typically incorporate their own set of different typical details and designs to fit their manufacturing system, while also meeting the design intent of the architect. So having these details designed directly by the manufacturer helps ensure that they are able to be manufactured in a high quality, safe, and efficient way for the project. Next, we'll walk through the reasons why a delegated design process is used and the benefits. The goal of incorporating delegated design for metal stairs is to lower overall cost improve the safety and performance of the stair systems, and improve coordination and efficiency of the design process. And we'll talk a little more about how each of these can be achieved. So how does it result in lower cost and reduced lead times? So because the designers and engineers work directly for the manufacturer, they will be intimately familiar with the manufacturer's standards for manufacturing. So they will design with manufacturing cost and efficiency in mind. They will also have an in-depth familiarity with installation requirements of their stair system, so they can design for minimal field welding and handling on site. The specialty engineer will also have an in-depth knowledge of the specific IBC load requirements and AISC guidance for stair design, so that all of these stair components will meet the load requirements, and the connection details will be designed per AISC guidance. And this is important because it ensures that the stairs will be designed with maximum safety and durability in mind. And then finally, a benefit is that it reduces design time for the architect or building designer in a couple of ways. One, the architect can incorporate information directly from the stair manufacturer into their documentation, such as typical details or specifications. The other way is that it delegates the detailed design work to the manufacturer, who will typically have more in-depth knowledge of the details of their systems, and will also have many aspects of the systems pre-engineered or pre-designed, which further contributes to a faster, more efficient process and frees the architect to focus on other design aspects of the project. In this next section, we will I'll talk about the roles of the architect and stair manufacturer and the documentation provided by each. The AIA document A201 provides the framework for the delegated design process. And first, it requires that the architect specify clearly that the scope of work in question, in this case, the design and engineering of the metal stair systems, is intended to be a delegated design component. And that should be clearly stated in the contract documents. Second, the AIA 201 document requires that the architect specify the performance and design criteria for the metal stairs, and that the design of the metal stairs require professional design services or certifications related to the systems being provided. And then finally, the architect would be responsible for reviewing and either approving or taking the appropriate action for the shop drawings or other product or quality submittals by the stair manufacturer, and checking for conformance to the design and performance criteria. So in this role, the stair manufacturer will be responsible for submitting a design which conforms to the contract documents, while the architect is ultimately responsible for reviewing and ensuring that it does conform to the contract documents, and particularly to the governing building code. The role of the stair manufacturer in the process is also threefold. First, the stair manufacturer must carefully study and compare the contract documents to understand all the design and performance criteria indicated in the documents. This will generally include a review of the architectural drawings, structural drawings, and notes in the Division 5 stair specifications. Second, after conducting the review, the metal stair manufacturer should report to the architect any known errors, inconsistencies, or omissions discovered. And this would pertain obviously only to the specific metal stair scope of work. And I'll go through a little later some of those common issues discovered during this review period. And then finally, the manufacturer should design the metal stair systems to conform to the design and performance criteria as indicated in the contract documents, and must make the appropriate submittals to document that conformance. This section, I will provide an overview of the design documentation and submittals required for a metal stair delegated design. The primary source of information for the stair manufacturer from the architect is the set of contract documents, and this will serve as the governing documents to which the stair manufacturer will conform their design. The documents, as it relates to metal stairs, typically includes the architectural and structural drawings and specifications. Often the architect can also provide BIM models of the building or stairwell. And the BIM models can be extremely helpful for the stair manufacturer, especially in identifying and locating clashes between the stair system and the surrounding building structure. One important consideration is how the BIM models should be incorporated into the design, and whether it's should be used as a for reference document or as a governing design document. So prior to use of models, the stair manufacturer will want to have some documentation as to how the BIM model should be incorporated. And then documentation from the stair manufacturer will include a series of submittals, typically BIM models, shop drawings, engineering calculations, and any other product and quality submittals. And this is an overview of the documents and information that should be included in each document. The information from the architect as laid out in the architectural drawings will usually include stairway layouts, egress dimensions and layouts, direction of travel, stairwell dimensions, of course the governing building code, and then details to indicate design intent for guardrails, handrails, and other product information. The engineer of record would provide additional information through the structural drawings and notes and details in the structural drawings. And the information from the structural drawings would generally need to include slab and beam dimensions and sizes to which the stairs are connecting. And then again, the stair manufacturer will provide a series of submittals to demonstrate conformance to the contract documents, and we'll go through those in more detail. First, we'll go through the documentation from the architect to the stair manufacturer. Some of the basic information provided to the stair manufacturer in the architectural drawings should include the stairwell wall-to-wall opening dimensions, stair floor-to-floor height dimensions, egress path dimensions, which would be the distance above the handrails between the guards. If it's an IBC accessible stairwell, the distance between handrails might be relevant. And then, of course, typical details to show the design criteria of the treads, risers, nosings, guards, and handrails. And we'll go through some examples in the next few slides. So typically the architectural drawings will include enlarged plan views of the stairwell openings to indicate all the necessary dimensions. The two of the most important dimensions are the wall-to-wall overall stairwell length and width. Also on these enlarged plan views, the door locations. And the enlarged section views typically will show the finished floor-to-floor heights, which is the most important dimension needed for the stair manufacturer. The intermediate landing height and individual stair riser heights. And if the intermediate landing heights and stair riser heights are not indicated, the stair manufacturer will typically assume an equal riser and flight height for each of those. The enlarged plan views should also indicate the wall construction and wall types and the widths of the wall enclosure, which is needed by the stair manufacturer to design the landing supports, which are typically hidden inside the walls. The stair egress widths, which is the clear width above the handrails between guards and or walls. The landing widths. In the details section, there will be a few general design criteria details needed by the stair manufacturer to successfully design the stairs, starting with tread and riser design intent. Most importantly, the tread type. In this example is a concrete pan stair. Riser heights and tread depths, and here is showing the 7-inch max riser and 11-inch min tread per IBC. The riser type and whether it's a closed riser or open riser. And an important note with architectural details and how they are incorporated or used by a stair manufacturer. The stair manufacturer will have its own standard details and for treads and risers, which are designed to reduce costs and lead times for manufacturing. So including a note here in the details section that the stair manufacturer's standards will be acceptable can help clear up some confusion later on in the process. And on the flip side, if there are any specific criteria that should be strictly adhered to by the manufacturer, including a note on these detail sheets can again help help clear up any interpretation issues. There is room for interpretation with architectural details, and often manufacturer standards will differ in small ways from architectural details. So helping to clear this up on the front end is important. The guardrail details primarily will indicate the design intent and the code criteria. From a design intent perspective, the details should indicate the guardrail infill design, in this case a vertical picket type guardrail. The posts design, including if there are any specific material types or profiles for the guardrail posts and frame, and then the handrail design. From a code perspective, the primary items and dimensions the stair manufacturer will be looking for are the guardrail heights, handrail heights, infill opening spacings, and handrail extension dimensions. If these dimensions are not all indicated on the architectural drawings, the manufacturer will typically design the railing per its own standards to meet the applicable building code. And again, as noted in the last slide, the stair manufacturer will have its own standard guardrail and handrail designs to reduce costs and lead time, which can often differ in small ways from architectural details. So including any specific notes as to which details will be should be strictly adhered to, or if the manufacturer standards will be acceptable, is always beneficial. Next, we'll go through the information in the specifications. Before I go through the specific information, I'll run through a quick overview of the different types of specifications and how they relate to delegated design process for metal stairs. A performance specification is the most common type used in this process, and it dictates the performance requirements, but allows for multiple manufacturers to propose their own systems, and allows for freedom for the chosen manufacturer to design using their own standard systems. A proprietary specification can also be used here. It's typically a specification that is used with a stair manufacturer's proprietary system, whether it be a performance, tread, or railing system. And then a prescriptive specification, typically not used here because it would defeat the purpose of delegated design process, which is to gain the efficiencies and reduce costs by leveraging the stair manufacturer's knowledge in stair design and engineering. So again, the performance specification, most common type used, and it allows, again, for multiple stair manufacturers to propose their systems, and it often can include a short list of qualified manufacturers to meet the performance criteria. Again, proprietary specification is typically used when a certain level of performance can only be achieved by a single product. In this case, relating to stairs, typically when there is some sort of performance tread or railing system. And as discussed, the prescriptive specification is not often used. The information in the specification will indicate, it'll have additional information needed to design the stair systems. First, most importantly, the engineering or structural performance requirements for the stairs and guardrails and handrails, usually per IBC live load specifications. It will also usually include a manufacturer's qualification statement, product and material requirements, submittal requirements for shop drawings, quality, lead, or other product information such as samples, finishes for primers, finish paints, and weld finishes, and then of course installation requirements. So what is needed in the performance specification? One of the important criteria listed in the performance specification is the requirement for enlisting a professional engineer to oversee the stair design and stamp and seal the drawings. And again, it'll also usually include the structural performance of the stairs. Additional information, it will list the manufacturer's qualification for quality. The specification document should list some minimal quality criteria for the design of the metal stairs. And this might include that the stair manufacturer should have a minimal number of years performing similar work. Stairs should be designed under the direct supervision of a structural engineer licensed in the state of the project. And then all welders should be qualified under an AWS certified weld inspector. Other design criteria that may be included can indicate the level of finishes for the welds of the stairs. And there's two organizations who have created standards. The National Association of Architectural Metal Manufacturers has classified stairways by different classes according to different uses. Industrial class stairs are primarily functional with limited weld finishing. Service class stairs also primarily functional but designed with appearance in mind. Visible welds in the travel area would be ground smooth. Commercial class are stairs for more public use and generally visible to the public. Welds in conspicuous places will be ground smooth. And then architectural class stairs are more elaborate and designed primarily with aesthetic in mind. And usually all welds will be ground smooth. For the railing finishes, the National Ornamental and Miscellaneous Metals Association has published specific weld finish standards for guardrail joints, and this is the most widely adopted standard for guardrail finish. And the classification classifies weld finishes ranging from a 1 to a 4, with a number 1 being the most stringent, with no evidence of a weld joint, and number 4 being the least. And similar to the NAM classification, the NOMA finish type typically correlate with how the stair is used and whether it's designed to be purely functional versus ornamental. And of course, in both cases, the higher the weld finish, the higher the cost. And the next section will go through some additional important information that should be provided by the engineer in the structural drawing package. The structural drawings should indicate the dimensions and other design and performance criteria to help the stair manufacturer design the connection details and supporting members for the stairs. So the stairs will be integrated with the building and supported by the building in many cases. So the dimensions needed will be the dimensions of surrounding building structure to which the stairs will connect. If relevant, any specific design criteria for connecting to the building structure. And then any other performance criteria, such as seismic loads. And we'll go through some examples. In a structural steel building, perhaps the most important dimension required for designing the stairs is the stairwell opening dimensions from the center line of surrounding structural steel beams, which is needed to to design the connections from the stairs to the beams. In a steel building with floor slabs, the dimensions from the floor slab to the center of beam is necessary to design the connections from the stairs to the floor levels. In many cases, the stairs will need to be designed with other performance criteria, such as seismic loading or another criteria is that stair loads may need to be imposed as concentric to the structural steel beams. This is a design requirement that's been recently recommended in the AISC Design Guide number 34 for steel framed stairway design. And it typically requires that any hangers from the stair landings to the beams fall directly under the center of beam rather than to the side or the web of the beam. And if for some reason hangers cannot be located directly under the beams, there may be some other, and one reason they might not be is because of other design constraints, such as hiding the hangers within the walls. So if this is the case, there may need to be additional kickers added to resist torsion on the beams by the stairs. And the stair manufacturer will need to know that, and that would usually be included in the structural steel details or notes. So we've gone through the requirements from the building designers, and I'll now cover the documentation that the stair manufacturer should provide to demonstrate conformance to the design and performance criteria. And the stair manufacturer, as noted, will typically submit a series of documents and other file types, including BIM models, shop drawings, engineering calculations, and other product and quality submittals or samples. If the manufacturer is working in a steel modeling software program, the manufacturer can provide BIM models of the stair systems to be directly incorporated into the building BIM model. And this allows the stairs to be integrated into the overall BIM coordination process and for the building designer to perform a clash detection check. The manufacturer's shop drawings or approval drawings should demonstrate conformance to the architectural drawings and the structural drawings and specifications. At a minimum, they should include all the dimensions in the plans and section views the connection details to the building structure, and then other details to show conformance to the design intent and the performance requirements, and of course the code compliance. So similar to the architectural drawings, the stair shop drawing should include enlarged plan views and section views. In the enlarged section view, the shop drawing should indicate the floor-to-floor heights and riser heights. The enlarged plan view, the shop drawing should show, again, similar to the architectural, show the wall-to-wall dimensions, egress dimensions, the landing dimensions, other dimensions to building grid lines, and the surrounding wall construction type. Shop drawing should show details to indicate how the stairs will be connected and installed into the building. So that would usually include the details of any welds directly to the building, hanger or column support structures for the landings, any other embedment plate details, and then details of how the stair flights connect into the building at the floor levels. Shop drawings should include a series of typical details to show code compliance of the guardrails, handrails, risers, and treads, and also to show conformance to the design intent. This would be typically for code compliance, the picket spacings, tread and riser heights, guardrail and handrail heights. And the stair, as we mentioned, must be designed under the direct supervision of a structural engineer. And a stair manufacturer will typically have many of its components pre-engineered. So they will incorporate a large degree of pre-engineered components. The structural engineer will then perform an engineering analysis and calculation on the final stair configuration as it's designed. The calculations will demonstrate that the stairs will at minimum pass the load specifications per the contract documents, and all engineering work will be performed, should be performed under the AIC Code of Standard Practice for Steel Buildings. Other submittals by the stair manufacturer might include the primer or paint specifications, product samples for demonstrating the rail weld finishes or tread finishes, the welder certifications, and then other certifications or quality procedures and manuals. The next slide, I'll go through a typical process flow and timeline for the overall delegated design process of metal stairs. So this flow chart lays out the typical process flow. It begins with the architect creating the overall layouts and designs of the stairs, and then documenting that in the contract documents. That could take any number of days or weeks, depending on the complexity. This goes to the stair manufacturer, who reviews and submits RFIs if there are any questions. And then the stair manufacturer creates detailed design models in a steel detailing software and produces the shop or approval drawings and performs the initial engineering analysis and calculations at that time. Then the architect will review and approve the drawings for conformance, will make any notes for revision, and the stair manufacturer will then make the corrections and either resubmit for approval or proceed to final engineering analysis and fabrication. And the overall process from when the stair manufacturer receives the design documentation could be anywhere from 6 to 12 weeks, depending on the clarity of information, the need for RFIs, and need for revisions to shop drawings. So with the amount of time varying so much, we'll walk through what are the typical issues and bottlenecks that arise throughout this process. So most of the issues arise from one of three sort of key sources. Missing information in one of the documentation sources, whether that be dimensions or details. There could be conflicting information because there are multiple sources of information. And there could be different ways to interpret information as shown in any of the sources of documentation. Missing dimensions in the contract documents that are needed to design stairs. These may include, as we went through, the wall-to-wall opening dimensions or egress dimensions, or floor-to-floor heights. Whatever these dimensions are missing, the stair manufacturer will issue an RFI to clarify. And again, just a section view without floor-to-floor height dimensions will trigger an RFI from the stair manufacturer. Other times there could be conflicting information between drawing details and specifications. In this example, there would be a stringer profile that's different in the drawings from the specification, a plate versus a channel. And this is a case that, again, this will trigger the stair manufacturer to issue an RFI to clarify the correct stringer profile. As mentioned earlier, there are often small differences between an architectural detail and the stair manufacturer's standard detail. This could be anything from riser bend radiuses, nosing configurations, tread carrier angle profiles, various small details that go into designing the stairs. So any notes stating that these stair manufacturer's standard details are acceptable or not can help with these types of interpretation issues. Additional interpretation issues is marked up approval drawings, whether there's multiple reviewer comments on the same drawing sets or information that's difficult to discern. Often here, the stair manufacturer may request a call directly with the architect to help clear up confusion on any of these types of comments. So now we'll go through some of the best processes and practices to help streamline the delegated design process for metal stairs. So, the most obvious one is to make sure that the dimensions we've laid out are included on the enlarged layouts and section views. One way to eliminate issues is incorporate information directly from the stair manufacturer into the documents, whether that's typical details from the stair manufacturer or use BIM models or specifications. And then adding the notes that stair manufacturer's details will be acceptable. And then finally, using tools from the manufacturer to help with the initial stair design and layout so that downstream design issues are reduced or eliminated. So providing clear documentation starts with the dimensioning of the enlarged plan and section views in both the architectural and structurals, ensuring that the slab and beam locations for which the stairs are connecting to and the beam types and sizes, and then indicate design criteria as necessary, such as stringer profiles, railing profiles and types, and any other conceptual details. The stair manufacturer, many have various resources available to help architect with the initial stair layouts and design. This include code compliance checklists, typical details, BIM models, specifications, and modeling applications that can create more detailed stair designs and models. And again, the stair manufacturer can provide guides and tools such as a code compliance checklist or model generators or software tools to help design the stairs. And this is an example of a code compliance checklist showing the different types of IBC use stairs with the different design criteria and allowable dimensions for each of those criteria. And then an example of a model generator for stair design. And that will conclude the presentation. I'll now pass it back to Andrea for opening it up to any questions.
Awesome, thank you so much. All right, guys, if y'all have any questions, now is the time to enter those in. Again, you can click the little arrow button or the plus button to expand the question panel, and then from there you can enter any questions that you may have. So while we're waiting for questions to come in, let's see. All right, so Sarah's question is, for public projects, when or / how does the manufacturer provide details to be incorporated into the contract document?
So for as to who those details would be provided to, the details I think can be used by anyone, whether it's a public project or not. And I think a particular stair manufacturer's details can be used in a project without them being making the details proprietary. So they can be used as standard or typical details, but also allowing through the performance specification bidding by multiple stair manufacturers. So I don't think using a particular stair manufacturer's details precludes the competition on a public project. I'm not sure if that answered that question or not.
Awesome, thank you for that. And she says, yes, it does. All right, so with that, we are going to go to Frank's question. Frank's question is a code compliance checklist available online for multiple stair manufacturers?
A code compliance checklist, I'm sure there are multiples out there. We have a code compliance checklist that's widely available online. I think I don't know if there's one available on IBC or site, but I'm sure a quick Google search can help find that.
Thank you. And then the next question is from Jessica. Her question is, what type of projects are you seeing this process most used in? For instance, I work on multifamily projects and have not used this process.
Yeah, we've seen it used really on any kind of project. I would say mainly in the commercial setting. Certainly multifamily projects, hospitality projects, office building and corporate type projects. But the process really could be used on any type of project. But I would say, mostly where we see it is any kind of commercial setting.
Awesome. Okay, and then Philip's question is it better to include the design of the floor landing in the main building floor design or the stair design?
The floor landing in the, I think I understand the question. Is it better to, I think what it's going to be better to, more cost effective in my experience, to include the floor landing as part of the building structure. If that was the question, usually that could be incorporated as part of the structural steel or a pour out of the floor slab versus a unitized stair landing. And that's usually the most efficient, cost-effective way to design the floor landings.
Awesome. So with that, we're going to go ahead and close out the educational portion of the webinar. So Ashton, I'm going to go ahead and open it up for you to tell us a little bit more about Lapeyre Stair and what you guys have to offer.
Sure, yeah, I'll just show a quick presentation here. This is an overview of a software that we're developing. It's a web-based stair design software. It's called Escher. Rundown is that Escher is a web-based tool. It's available on, will be available on lapeyrestair.com. Simple, it's based on simple input forms, which will allow the creation of code compliant and manufacturable stair models. So the models that are created through these inputs are shop level detailed. They're not typical BIM models. They can be fully manufactured from these models. And they will be, what we're currently working on is being able to download these models and directly import them into Revit. So ultimately, it would eliminate the need to create custom shop drawings based on interpretation of contract drawings. And the shop drawings will be automated based on the BIM model as created and imported by the architect. So if you recall the flow we went through in the educational portion, this Escher process will be measured in hours and days versus weeks and months for designing and approving stair systems. Creating a model in the Escher software will take about 15 minutes or so. And we'll do As I mentioned, we're currently building 2 versions of this platform. One will be a web-based tool for architects and other designers to use. We're also using this actively in our internal group to design stair projects, live stair projects now. We're in a beta testing mode, so if there's any interested parties, we'll be recruiting for beta users of this software. We'll go through a quick video here showing how this works. So this is you sign up for an account, log in, and it's a web-based platform. We're building out the ability of the platform to handle different types of stair configurations, but you just enter in your project information and building information. It'll help calculate egress widths. Choose your material types for guardrails, your configuration for orientation of the stairs, your floor-to-floor heights, and overall plan view dimensions. And the platform will check to make sure that your inputs are code compliant. And then you would submit your design, and it would create a model. The model is created in our structural steel detailing platform, and we're currently working through the process to take that model and import it directly into Revit without any other BIM software without losing any information. Long term, we'll have all of the documentation automated, but currently the model is our most immediate. Sorry about that. So this is a couple of live projects we've used the software on. This is a project in New York City. It'll be the 6th tallest high-rise in the city, from what I understand. Another project in the Philadelphia area. And that is it for me. Andrea, anything else?
No, thanks again for that great presentation. Alrighty, guys, thank you so much for being with us today. We greatly appreciate you being with us. I know that there's other questions that are coming in, but unfortunately we are out of time. So I will get those back to Ashton and have him reach out to you regarding those questions via email. So be on the lookout for that. Again, just a friendly reminder that if you are attending and you do have a group participation under your login, you are considered to be a group manager. And as that manager, I need you to report your attendance within 24 hours of receiving that thank you for attending email. Now, if you have any questions or you need to get a hold of me, you can always reach me at webinars@ronblank.com. So until next time, I hope y'all all have a wonderful day. Bye.